Today is Tuesday, May 4th, and this is the fourth period class recording for Math 2. This file for similar triangles, lesson 4-5, is not the same as the one in Canvas. This is a blank version of the file that I'm going through and writing these notes on from the beginning. So one thing you should notice, like at the top of the file, if you're looking in Canvas, which if you guys didn't copy these notes at all and you want to view the file in Canvas, I'm fine with that. So we've got yesterday, we should have completed the mid-segment lesson. Today, we worked on CUDA, the beginning part of class. So now we're looking at similar triangles lesson. And we've got this file here. Sometimes they load automatically, sometimes they don't. If it doesn't load automatically, if you click on it, it should load the preview in Canvas. And this just took me out of student view. Should load the file. I guess it just wants to do that. I don't know if there's a certain way you have to click it for it to, there it goes. And I can update that so it opens automatically. I thought it was already set that way. So this file is the version that I would have liked for you guys to copy yesterday, but it was not a part of a assignment grade. It just would have made it easier if we copied this ahead of time. And so all of these notes here we're going to discuss and reinforce, but they are not written in the blank file that I'm going to be going over on the board. So you see there's some of these, you try 11, 13, 16, 17, 18, etc. I don't know why that did that. My computer's being weird. Go away. Okay. So if we're looking at the top of the page, similar triangles have equal angle measures and sides that are proportional to each other. So we need to make sure that we understand what a proportion is. So we're going to be doing lots of cross multiplying, lots of simplifying fractions, that kind of stuff. There's 3 different ways we can prove triangles are similar. The double angle similarity, understanding that if we know 2 angles of a triangle, we can find the third one. Double angle just sounds better. There's no specific reason why we're not considering the fact that if I know that 2 angles are congruent, the third one is also congruent. That's just understood because we should understand the principle of triangle sum. Does that make sense? So that's one way. So if 2 angles are congruent, the triangles are similar. Understanding here that this order matters. Triangle ABC is similar to FGH. The order matters because angle A is the one that's congruent to angle F. Angle B is the one that's congruent to angle G. And angle C is the one that's congruent to angle, and I didn't really use pink again. And angle C is the one that's congruent to angle H. So that order is what sets up our similarity statement, and that tells us that sides AB should be proportional to FG, and AC should be proportional to FH. If we don't write that in the right order, it's going to mess up our proportions. So we need to make sure that we understand how to write the similarity statements. One of our other theorems for triangle similarity is side, side, side similarity. So if all 3 corresponding sides of 2 triangles are proportional, then they are similar. So if I had something like 6, 8, and 12, and this one was 3, 4, and 6, those sides are proportional, correct? So understand that it might not always be something as straightforward as that. It could just end up being two proportions that simplify to the same value. So don't think of it as, oh, I have to be dividing or multiplying by the same whole number. It might not be as obvious or as straightforward when we're looking at our proportion. So make sure that we always follow all the way through with simplifying or solving our proportions. So when we're talking about side angle side similarity, so understand that these two theorems are also will also come up in congruence. So we'll also be talking about side, 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 and side angle side next week when we get into triangle congruence. The most important thing here about side angle side similarity is that the congruent angle has to be in between the two proportional sides. It's the included angle. It's the included angle. And we would have to check the proportions for these. So this is saying something that we have to go through and verify to make sure, unless it tells us. And if it tells us these triangles are similar, find the missing side, then we can just set up our proportion and solve. But if it's telling us to find out or see if, verify that the triangles are similar, then that's when we need to go in and check. So there's two different ways we can check our proportions. And it really depends if we're given, how much information we're given. Because if we're given a variable as one of our sides, we're going to need to cross multiply and solve for the missing side. If I'm given all of my side lengths, then I just need to set up my proportion and simplify to see if it creates equivalent fractions. Jewel, does that make sense? You can get some water if you need to. We got questions on these three similarity processes. So I was trying to think of, because one of them is a postulate, one of them is a theorem. So, and knowing that doesn't really matter. Knowing that one's a postulate, one's a theorem doesn't really matter. Does everybody understand that piece? Okay. So here on this page, I left this blank because looking at this page, it's a whole lot of stuff on here, and it might be tricky to see how it all came to be. So the first thing I notice when I look at number one is that these lines, XY and VW, are parallel. Because those lines are parallel, that creates this transversal here and this transversal here, to where now I have alternate interior angles and I have vertical angles, right? So based on what we know about parallel lines and vertical angles, we're trying to determine whether the triangles are similar. So yes, for number one, these triangles are similar. And they're similar by the double angle postulate. So Lonnie, we're on the next page. We're not on that page anymore. We're on the top of the next page. So yes, these two triangles are similar by the double angle rule. And our congruence, this is where we have to be careful. And I'm going to erase these lines so that we can see what our angles are. So by alternate interior, Y and V are congruent. By alternate interior, X and W are congruent. And by vertical, that was supposed to be pink. By vertical, Z is congruent to itself. So triangle, if we write this in order, X, Y, Z is going to be similar to triangle W, V, Z. Very good, because we have to make sure that we match up our congruent angles. Does that make sense? So that was not, and it looks like in the notes I wrote this backwards. Let's triple check. Let me make sure I didn't. Y. Yeah, that was just a mistake in the original notes. Because even looking at the way I drew this diagram, I clearly marked Y and V as being congruent. So this is the correct statement. I'm going to go in and replace this file when we're done. Does everybody understand why number 1 is an example of similar triangles? All right, so number 2, what kind of triangles are those? Right triangles. So can I find BC and EF? Can I find those measures? If I have a right triangle, how do I find the missing side? What do I need to do? There's a specific theorem that we use when we're dealing with right triangles. What is it called? Starts with P. Pythagorean theorem. I keep having my alarm yesterday. So funny story, yesterday my alarm was set for 12:15 intentionally because I was supposed to leave because I had an appointment. Luckily, I didn't miss it. I was still there on time. It was fine. So that's why that alarm was on yesterday. And I just forgot to turn it off today. So Pythagorean theorem. Who remembers Pythagorean theorem? There we go. A squared plus B squared equals C squared. So in my first triangle ABC, which side is my hypotenuse? So angle A is 90 degrees. Which side, so you need two variables, Audrey, which side is the hypotenuse? BC. So in your Chromebooks, we can find, using your calculator, we can find the length of BC by taking the square root of 3 squared plus 4 squared. In your calculator, everybody do that. Find the square root of 3 squared plus 4 squared. Tell me what it is when you get it. 5. You should get 5. So if I'm looking at my other triangle, DEF, is EF the hypotenuse or a leg? The hypotenuse is opposite the right angle. Is EF opposite my right angle? No, so this is going to be a leg. So here we're trying to find either like an A or B if we're thinking about in terms of this equation. So if I'm trying to find EF, that's going to be equal to the square root of 10 squared minus 6 squared. Because if we're thinking about A squared plus B squared equals C squared, if I'm solving for a side, I need to subtract and then take the square root. So what is EF? 8. Very good. So now I have two sides, right? I have two sides with an included angle, yes? So I need to check, is AB proportional to DF? Is AC proportional to DE? So if I look, 3 to 6, 4 to 8, does that feel proportional? Yes. So if we were to write this out, so this is proportional by side angle side or side side side, because if we go through and verify with that last side, 5 and 10, that's still going to be proportional. So if I have 3, 4, 5 proportional to 6, 8, 10, those are all equal. Understand that we could also write it as two separate ones if I did 3 over 4, 6 over 8. So we can either do one triangle on top, or if we do one triangle on one side. Does that make sense? How both of those are going to equal the same thing? Because even if we picture this, when I cross multiply, I still get 6 times 4 and 3 times 8, right? So number 2, yes. And we can say either by side, angle, side, or by side, side, side. And this similarity statement is going to be what? What would the similarity statement for this one be? Right on your boards, on your whiteboard. So if we have triangle ABC is similar to triangle what? So write the first one ABC. And what would the order have to be for my second triangle? Yes. Yes. Wait. Maybe. D. D. Let me see. I don't know. Might check that one. Alani, Audrey, check that one. So are we? So look at, and you guys are all getting the same thing. This is making me second guess if I'm doing this wrong. So make sure that we're looking at our side. So if we're saying that our second letter, bless you, should be, if we're looking at FED, does FE correspond to AB? Look at the sides. What is side FE? 8. FE is 8. Does that correspond with AB is 3? So you have to make sure our corresponding sides line up. So which side is corresponding with AB? That'd be FD. Which side is corresponding with BC? That'd be DE. Which side's corresponding with AC? FE. So we should have similarity statement. Triangle ABC is similar to triangle FDE. So the reason I can't have E in the middle is because AB does not correspond to FE. It corresponds to FD. So we can use our letters to match up with our sides. Does that make sense? How we looked at that? So whatever order your letters are in, those corresponding sides should also match up. That's the one way that we can check that. So number 3 is not similar because 6/4 does not equal 8/5. It's not going to simplify. Now for 4, this is one where we're kind of reviewing unit 1 with this as well, because I have to visualize that this is a line of reflection right here. So if I flip this triangle, that's how we're going to have it match up with itself. So if I have 10, 15, 20, that's corresponding with 4, because if I flip it, then 4 is on this side. 4/6, because the base, over 8. Do those all simplify to the same thing on your boards? What do we get? What is the ratio? Simplify. What do those all equal? Simplify on your board. Very good. Very good. Yes. Awesome. Yes. Good job, Gordon. Nice. Good job, Eric. Yes, ma'am. Good job. Yes, good job, Ellie. So this is one where you have to understand that they aren't necessarily going to all simplify the exact way that we would kind of expect, but we can look at each individual fraction and simplify it. So I know 5 and 4 have a common factor of 2, so I get 5 halves. 15 and 6 have a common factor of 3, so I get 5 halves. 20 and 8 have a common factor of 4, so I get 5 halves. So yes, this one is similar by side, side, side. And my similarity statement, if we're looking at triangle JLK, is going to be similar to triangle what? What order do my letters have to go in? SRQ. Do we agree? SRQ. So if I have SRQ, that's saying that JL corresponds to SR. Yes. That's saying KLK, KL, whichever one want to say it, corresponds to RQ. Yes, that's true. And then our outside 2. JK corresponds to SQ. So that's the statement for that one. So for these last two, before we pack up for today, I want us to redraw these. So I want us to redraw this so that they are in the same position. So if I have J, K, it's going to be on this side, and L, because not only is this rotated, it's reflected. So we need to rotate and reflect. So this puts 51 degrees here. That's my congruent angle. KL is X, JK is 4. Draw this as 2 separate triangles where I have V, Q, and S, S, T, and R. VS is X, TS is 12, RT is 3, QV is 5. So this is going to make setting up our proportions a lot easier. So we can set these up one of two ways. We can either set triangle over itself. Oh, I lost my earring. That was crazy. Okay. So I can either set this up as 4 over x equals 5 over 15, or realizing that's going to be the same if I set it up as, and it doesn't matter if we put 5 on top, 5 over 4 equals 15 over x. Same concept here. 5 over x equals 3 over 12, or 5 over 3 equals x over 12. The main thing that matters here is that when we cross multiply, we should get the same thing. So there's more than one right way to set up a proportion. So once you get those set up, we can pack up and we will review these in class tomorrow. So our main tasks for tonight are CUDA and Khan Academy.